So again, we're having this idea of where is something defined, then expand and simplify. So first of all, we'll figure out where it's defined. Do we have variables? Yes, we have the variable b. Is it in a square root? Yes. Can't square root negative numbers, so our b's have to be bigger than or equal to 0. If our values of b are positive numbers or 0, then we have no problems. But if our b value was negative, then we'd have a square root of a negative, and that can't happen. So it's only defined when b is bigger than or equal to 0. Okay? I look at the first one. Is it conjugates? No. So I'm not going to be able to use a shortcut. All I can do in the first one is multiply. And, oh, how do I do 7 times 3? What are the rules? Well, that's just regular math. Right? 7 times 3, that's just 21. Okay, not so bad. And then I'm going to have 7 times, and I have square roots. So what happens if you don't have square roots in one and you do have square roots in the other? Same thing. We multiply the outside numbers. So 7 times negative 5, negative 35, and then we just have the one square root. It stays just the square root of b. Same thing in the middle. I have 2 times 3. That's going to be 6. And the root b, there's only the root b, so wow, that looks like 6. And finally, I have the 2 times the negative 5 is negative 10. And the root b times the root b, okay, will be root b squared. I'm okay if you just get rid of the roots and write b. Do I need absolute value bars around that b? Okay. So first of all, if you do this, I won't take off marks because it's still true. But in this situation, it's not needed. Why? Because b is already positive. Because root b times root b is technically root b squared. And when you square root b squared, you need absolute value bars, unless b is already defined to be bigger than 0, then it's not necessary. Huh. So a lot of times it's not necessary, and then when it is necessary, we forget to add them. So I'll keep talking about it just to, I don't know, continually confuse you just a little bit, or make you think about it, but it's good thinking to do. And now, do we have any like terms in this? Yes. These two in the middle, these are like terms, so I can put those together. I'm going to get 21, negative 35, plus 6 will be negative 29. Oh my goodness, I'm having trouble writing the letter B today. And 29 root b, and then minus 10b. And like I said, we don't need the square root on that. Oh, I can't guarantee it, but if I give you question B, and I mark them, you guys are going to make me frustrated because it's so easy to make little mistakes in B. Okay? So first of all, in B, I'm going to notice the shortcut in the first part. You notice that you have conjugates. You have the same first terms, the same last terms, one is plus, one is minus. So we are able to use the shortcut and say, if I multiply those, I will get the first one squared minus the last one squared. That's perfect. Where the mistakes happen is in the second part, because we've got a subtraction sign here. Technically, this means, I'm going to write it out because I think it's worthwhile to write it out. It means multiply by itself. have to do the errors. So, if I square this, oh, we didn't do where it was defined. Let me just take a moment before I get too far and talk about where things are defined. Because it's going to make a difference whether I have to use absolute value bars or not. So, checking this out. X has to be bigger than or equal to 0. Inside a square root, I have a y. Y has to be bigger than or equal to 0. Does that work for everything? Yes. So there's where things are defined. That becomes important here because when I square 3 times the square root of x, 3 squared is 9. Square root of x times square root of x will just be x, and I don't need absolute value bars because x is already positive. Minus square root of y times square root of y is just y, and I don't need absolute value bars because y is already positive. Minus. And now I'm going to multiply this all out, and I'm going to make a little mistake, and you're going to see if you can find my little mistake while I multiply it out. I'll try to be tricky and try to hide it, because I don't want to admit I like to make mistakes. Let's see if you can find it where it goes. I'll even add some shortcuts to sort of seem like I might be cheating a little bit. So, let's see if you can catch my mistake. Okay, so root x times root x, that will just be x. Root x times 5, we multiply the numbers in front, which is 5 times 1, which will be 5, and root x times root y will be root xy. And then, mistake wasn't that I accidentally wrote it down wrong to begin with. That was actually an honest mistake that I did not do on purpose. So if you thought, oh, I see it already, that was just bad teaching. Okay, that's right. So, multiplying the second one, again, it's 5 times 1, that'll be plus 5, and root x, or root y times root x will be root xy again. And the order doesn't matter. Y times x and x times y are the same, so that's okay. And then 5 times 5 will be 25, and root y times root y will just be y. I don't need absolute value, so this is fine. Okay? So I have it. Absolute values, no, that's okay because y is bigger than 0, x is bigger than 0. And I made a little mistake. Oh, we got hands up already. Just wait a little bit. Let other people look for it. See if they can see where that mistake is. And if you can't see that mistake, that's because you guys are so good at making this mistake. I tell you, over and over again, I make this question, I'm like, oh no. They're going to make the mistake, and I'm going to have to take off marks, and I don't want to, but they're going to make it. All right, Tristan, what do you know?
You forgot the brackets.
I forgot the brackets. Since I am subtracting all of this, even when I expand, I am still subtracting all of it. So I need brackets here to still say I'm still subtracting all of it. And then that negative will get distributed to every single thing here. So if I write things out, I have a 9x minus a y, but now I'm going to minus an x. Notice these are like terms. You'd have 10 of them, but they get hit by the minus, so it's minus 10 xy's and minus 25y. Now I have some like terms. 9x minus x is 8x. Negative y minus another 25y's is negative 26y's minus 10 xy's. And we just have to circle number